Good day, Minecraftians. Purple Mentat here, bringing you something a little bit new. I'm going to do a Terse turbine tutorial. I want to show you all how the turbine was built, and unfortunately in my last episode, things got a little wonky, what with the muting of the mic and all, and I'm going to need to do this little episode if I want to actually show you how I'm putting the turbine together and why I'm making the choices I'm making. So, let's just get right into it. And I'm going to stick the next turbine, right off of here. I actually didn't need that stone. Goodbye, stone. So, a turbine does have a few size limits, which are configurable in the Big Reactor's config file, but they're not really what limits them. In this pack, turbines are limited to being 16 blocks long. Either X or Y can only be 16 blocks. And when it's limited to that 16 by the config file, that also limits it to 32 tall. So twice the horizontal length. So I'm building my turbines up. I originally decided on it for aesthetics, but as it turns out, it's the right idea for mechanics. It helps with everything because I like to have my turbines 7 by 7 by 17. And the reason for this is it allows me to get my 36 coils and my 80 blades. And why do I need 80 blades exactly? Well, if I go into the turbine controller and I take a look at the max flow, that's limited to 2,000 millibuckets a tick, or 2 buckets per tick. That is the max amount of steam that a turbine can ever process. So making this turbine any larger would not be at all useful because I am looking to hit that 2,000 millibuckets a tick point. So that's where it's at. That's all there is. That it's no use at all to build it bigger because there's no more steam that I can pump into it. It is an innate limitation of turbines. Now, what does this mean in terms of the resources you need? Well, every turbine rotor blade that you use can support 25 millibuckets of steam being pumped into it. And then each coil can use a certain amount of that steam. So behind the scenes, it gets very complicated in that the rotor blades generate rotational force, and the coils bleed off that rotational force and limit it to a certain RPM. But basically what the end user needs to know is that the coils can use an effective amount of steam going into it. I don't actually understand all of the math. I tried looking into the Big Reactor's code, and it is far beyond me. I'm not a coder by any means. No, come back. It's gone forever. I do not know the programmings, and Java is, I can barely understand the basics if I have to, but yeah, no, it's not happening. So what we're going to be doing here is we're going to build the shell. And what I like to do is have a 7 by 7 on the bottom. And right in the center of that, you're going to want your turbine rotor bearing. You need one of these per turbine, and it needs to go into the side that you want the steam to be basically blowing from. And extending from that rotor bearing, you need to have your turbine rotor shaft. Now, with a 7 by 7 by 17, you can fit 2 rotor blades coming off each side of the rotor bearing. The rotor shaft. For a total of 8 blades per section, meaning you need 10 sections to get the 80 blades in there. You could extend this to a 9 by 9, an 11 by 11. You could make a really big fat turbine if you wanted to. However, in my testing at least, this was the most efficient size because those coils have to be within 1 block of the rotor shaft from what I was able to find. No matter what I did, I was not able to get a turbine to build with less than 5 shafts for the coils. It's just the way it is, unfortunately. So I'm going to continue building the shell, and I'll cut back in to show you the finished shell and talk about any other decisions made along the way. Alright, here's your shell mostly built. One of the cool things about big reactors, and it transfers over to the big turbines, anytime you can right-click the housing, and it'll tell you, block not valid for use in the machine's interior. What block are you talking about? All the blocks in there are valid, I think. It'll tell you the exact coordinates of any problems. I don't think I have any stray blocks. Error. Maybe. Anyway, we'll go back to that. I don't think there's an issue going on here. So you need at least one turbine power port. I have my turbines hooked up to Tesseracts that are sending on my default power frequency. And the reason for that is Tesseracts have no throughput limits, so I wouldn't need to get like 4 power ports. To support one of my other turbines that's producing 23,000 RF per tick, I would need to put in 3 power ports with the redstone cable. Redstone cable? No. Conduits. That's it. Whoops. Yes. There we are. Redstone energy conduits. It would take 3 of these attached to it to be able to output all of the power that one of these turbines can create. So instead, I just use 1 power port attached to a Tesseract. Now, as I was saying, you want Enderium blocks for this. The reason you want Enderium blocks is because each Enderium block can siphon off the maximum amount of power and has a bit of a power multiplier built in. You will get about 2% more power out of Enderium than anything else. Now, it is possible to mix and match the blocks. So, if I were to go over to, for example, this turbine here, and then take a look, I can see that I'm running a little bit over optimum speed. There's more power in there than I am sucking up at maximum. And if I take a look at the spreadsheet, which will be linked below one more time, then I can see exactly how much more, well, I can calculate exactly how much more I need. So the quote-unquote block cost on Enderium, that is the maximum amount of steam that each block of Enderium can support, is 54.13 millibuckets of tick, more or less. So with 36 of them, I'm at 1,948.68 millibuckets per tick, which leaves me a remainder of 51.32 millibuckets per tick. Out of what we have available, the best bet to use up the rest of that, if I wanted to really get every possible bit out of my reactor, would likely be a block of titanium from mariculture or a block of fluxed electrum. So I don't have the ability to produce titanium in this world, and I'm not going to cheat it in just to make the point, but you can get slightly more out of your turbine if you use that extra block. And it's just possible that using 37 blocks of Enderium will be a little bit better than 36, and we're going to test that in this tutorial, because I'm building another turbine, why not? So that is 3 layers of 8 so far. You have to wrap them right around your coils, right around the turbine shaft like this, or they won't work. It will tell you, for example, if I stick one there, and oh, it's still telling me the block is not valid, blah, blah, blah. Hang on. Let me finish forming this up real quick. You're going to need 1 controller in the turbine, and you're going to need at least 2 fluid ports. I'm going to get away with using 2, but you might need more if you decide not to use the transfer method that I'm going to use. So let me complete that, and it should build. And if it doesn't, then it didn't. Alright, so let me figure out what that invalid block message is. Be right back. Oh, nope, there we go. That's why it's not building. Found 1 metal blocks which are not in a ring around the rotor. All metal blocks must be in rings or partial rings around the rotor. So we're going to come back up top here, and we're going to make ourselves a hole. And then we're going to fall because I can't double tap spacebar fast enough. Alright, here we go. Finish up this ring of 8. So, yes, they need to be in those rings. 8 is the maximum you can get per ring. 4 rings get you 32, and then I'm going to put in 5 more for 37. I've been using just 4 extra for a total of 36, but let's see how 37 does for us. Oops, that's right, my exit's up here. Now, the fluid ports. Red means fluid going in, blue means fluid going out. Simple as that. Grab myself some Tesseracts. I need 3 more. There we go. I don't actually have Tesseracts set up on the reactor yet. So, on the fluid going out, that's going to be your water leaving the turbine. And you're going to want your turbine set to vent closed if you're going to do the closed system like this. So you put in your Tesseract, and I'm going to make myself a water frequency, which we're going to set to, I don't know, 97. Why not? I am also going to make myself a steam frequency on the red port, or the input. And that can be 98. Fantastic. Now, if I come over to my big reactor, I'll see that the reactant coolant ports work in a similarly color-coded manner. Their blue is for water coming in, so it will match the blue of the water going out of the turbine. And their red is the steam going out, so it matches the red of the steam going into the turbine. So which fluid is going through is nice and color-coded. And I really hope that that's actually a blue and not some sort of really strange green. In any case, I'm going to set the steam on this Tesseract, and it's going to need to send fluids. Just like if I go back over here, the water Tesseract needs to send fluids and nothing else, and the steam Tesseract needs to receive fluids. I'm terrible at these configuration. Receiving fluid on steam, sending fluid on water. And the reactor is sending fluid on steam and receiving fluid on... That was odd. Hang on a second. There, that's a little bit better. Just had to relog real quick. So, that's right. Sending fluid on steam and receiving fluid on water. There. Okay, and the reason I'm using Tesseracts is they have no throughput limit. To get 2,000 millibuckets per tick out of using fluid ducts, I would need something like 8 or 9 fluid ducts just for the steam, and then a similar amount for the water. Finding the exact limits on fluid duct transfer rate per connection is proving to be a little bit difficult. But the bottom line is that it doesn't matter because Tesseracts will move all of it all at once. It does not matter how many turbines I hook up to this Tesseract, all of them will be fed with steam. And it doesn't matter how many of them I hook up to this one, all of the water will be moved back into the reactor. There are other options in other mod packs that can accomplish this. I believe that both the Extra Utilities transfer pipes and Ender I/O cables are able to move an infinite amount with the right upgrades and configuration. I'm not certain about any other potential methods. But if you have big reactors, you probably have thermal expansion, so you might as well use the fluid ducts, in my opinion. Alright, so this reactor is all built. It just needs to be activated because it's being fed with steam and the water is being taken away. So then all there is to do at the end of it is click activate, and steam will begin to flow. It will use all of that steam every tick. Make sure that the rotor is... Something's going wrong here. Let me debug this. I had my sending and receiving backwards. I should be sending steam from the reactor and receiving water on the... Whoops. Oh, I have them both set to steam. No wonder there's a problem. I wasn't getting any water back into my reactor. Hang on here. Alright, so this should be sending steam. You are sending fluid steam. Fantastic. This should be receiving water. There we go. And I'm probably going to need to add more water to the system because it probably dumped everything. And now I imagine all of these are having issues now. Yep. Okay. That's a simple enough prospect, though. I can just go to my system, grab a Tesseract, set you on to my water line, and tell you to send water. Fluid mode send. There we go. And that should get the reactor filled back up, which will fill up the turbines fairly quickly. Just going to take a little bit of time. There we go. And now that the reactor is filling up its tank, it's time to take that Tesseract off. Because if we completely fill the entire system, well, that won't work out for us. There we go. And this guy should be gaining speed again. He is. Good. So yes, make sure that you actually have your Tesseracts configured properly or it won't work. Sorry about that little derp. So we're going to let this guy get up to speed and see what 37... Oh, energy buffer full. Well, it'll keep running while the energy buffer's full, but it shouldn't be filling up because I've got my power tap. Oh, you know what? All of the energy buffers are filling up because I'm not using anywhere near enough power to actually justify the amount of turbines that I have. Now that I have the turbine up to speed, looks like it's running at 1,797 RPM, which is just about in the sweet spot for 24,071 RF per tick. Compared to a 36 Enderium block turbine, well, you're getting about an extra 400 RF per tick out of it. So you can decide if that little bit of extra RF per tick is worth the extra Enderium block. 36 or 37, either way, you're in pretty good shape. So there's your basic big turbine. 1 rotor bearing, 15 shafts, 80 blades, 36, maybe 37 blocks of Enderium, about 320-ish turbine glass, around 2 or 3 stacks worth of turbine housing, 2 fluid ports, 1 controller, and that's it. Functionally, there is no difference between the turbine glass and the turbine housing. They are effectively the same block mechanically. However, if you build your entire turbine out of turbine housing, then you don't have these graphical effects. They literally do not animate at all. So if you're having problems with too much graphical effect on your computer and it's slowing you down, take out the turbine glass and put in turbine housing. Your computer will thank you. So that basically wraps up the turbine tutorial. There's not a lot to them. They're fairly simple compared to the reactors. There are a number of blocks that you can use for your coils, but Enderium is literally the best. You will get more power per steam from Enderium than anything else. If you are not producing humongous gobs of steam the way I am... Oh, I'm actually not producing enough steam at the moment because I have my my reactor limited. Whoops. We're going to just, whoops, go the other way. Drop that down to 30% on the control rods. Yeah, now we're producing more than enough. Fantastic. You are active. Huh. I don't know why the casing heat's that low. It's a little weird. Probably because it ran completely out of water and then got filled up with a ton of water all at once. In any case, yeah, that tells you basically everything you need to know about turbines. Let me know in the comments below if you have any more questions. I'll do my best to answer them. And thank you very much for joining me. See you next time.